So yeah, I'm Michelle. I'm a senior data engineer at Shopify, and today I'll be talking about how we use how we use DBT to improve data quality at Shopify. So Shopify is an e-commerce platform. We have tons and tons of data because we have to collect data about our own products, but also effectively we're a warehousing solution for more than 1 million other businesses. As much as we push things in terms of just data volume and scale, I think we also really push things in terms of how big our data org is. We have hundreds of data scientists, just over like 60 data platform engineers, 15 plus and always growing kind of service lines, which are these macro teams that data scientists are in. And in our existing kind of data modeling Spark-based monolith repo, we have about 100 PRs merged per week by data scientists. But today, for the scope of the talk, I'm going to be talking about a new modeling tool that my team has introduced. Also, I guess in the same timeline as Jason, about 8 months ago, where we are kind of packaging up DBT with Google BigQuery to provide a SQL-based modeling tool. And really what we added on top of that, which was unit testing, and unit testing the SQL logic that, that users supply for their models. So our motivations for unit testing SQL in the first place are definitely very similar to motivations that you would have for unit testing in a conventional kind of software engineering practice. The main thing is that we really just wanted to give data scientists the ability to assert that their model behaves as expected generally, and also in edge cases that may or may not even be present in the data yet. Another big motivation was just performance, which translates to iteration speed for data scientists, where we can run checks on production data sets, but those will be periodic, not frequent, not really something that you can run on every change or every commit, for example. The other main motivation is the fact that we have tons of data scientists and tons of collaborations on these data models, so that there are frequent updates and, like I said, many collaborators for a single model. And unit testing would really just give data scientists confidence that the changes that they're making to a model that they don't necessarily own won't introduce regressions into the existing behavior. We did definitely look into DBT and its provided data tests, but it doesn't really solve the use case of unit testing. Unit testing is really something that we do in addition to supplying data quality checks through DBT data tests. But just so that we're on the same page, DBT data tests are custom SQL queries that run against production data sets, and they fail if no rows are returned by the test query. And the main downside here is that it's difficult to capture and isolate edge cases in production data. And it's also slow and costly to test for a test that's meant to run on every change. Ultimately, it's running against production data sets. So what we need for any unit testing framework is really the ability to stub out or mock out our inputs, run our actual logic, and assert the behavior. So we really need the ability in the SQL context to replace any references to production models with some static mocked out data. Just a quick run through of what that kind of looks like in SQL. Let's say we have the simple model that gets all of the new shops that were created after a certain time. We use just the DBT source macro to dynamically refer to production data sets. So in a unit testing context, we kind of just want to cross that out and instead really reference a CTE, for example. The CTE is hard-coded by static data that's supplied by the user. You can do that for all of your inputs and then effectively run that same one test query that represents, I guess, building the actual model with some static data supply. So we went through a lot of different trials with this, and after a few series of iterations and alphas and betas, we landed on a unit testing framework with Python. Can elaborate later on why that choice, but at Shopify it made a lot of sense with the data science experience. Some of our goals for designing the Python interface were to really nudge users to be able to write unit tests that fail for a single reason. And for that, we needed to make it easy for users to write multiple tests. Some behavior that we've seen a lot in alphas and also in our PySpark system is that we do have unit test capabilities, but users just write one unit test, just sort of super happy path and call it a day. So to achieve that, we wanted to make sure we reduce the verbosity and the redundancy that's necessary to specify and write unit tests. We also wanted to introduce support for more granular assertions beyond just equality, beyond just saying running with these inputs gives me this output. exactly. And we also recognize that there are these data scientist personas and wanted to give users flexibility in the mechanism that they encode static data. It doesn't really matter as long as they're encoding it. Some people really like a tabular CSV style. Others like more like a data frame or Python list of dictionaries. So just acknowledging that this is just a preference, and we wanted to give users flexibility there. So what we came up with was a unit testing framework where the central kind of object is this mock model object, and that represents some static data with a schema. Here we can see on the right this little code snippet of an example of how you create a mock model. And there are 3 different constructors. You can construct this from a dictionary, a pandas data frame, or a CSV style string. But you specify the name of the model that you're trying to mock out, and then the static data. Here's an example of the data frame, and this is kind of what the inline CSV looks like. I actually really like how this reads out when the whole test is written. It reads very like story-like, and it's very easy for review. Then to make the actual mock model with the inputs supplied, it's still a mock model. We use a different constructor and pass in the name of the model we're looking to test, as well as a list of its inputs. Then we can compare it against an expected model. I didn't have space to write it here, but effectively it's also just static data. So you can construct it from a CSV, pandas data frame, or Python list of dictionaries. So we do supply this just basic equals method. But in addition to that, we also integrated with great expectations, and you can use any of those expectations as assertions in unit testing and say things like, my actual model expects column values to be unique. So having more granular assertions, again, trying to nudge users to write very well-scoped unit tests. Okay, so how did this all go? How's it all going for us in terms of the unit testing? Since we launched, we have over 100 models submitted from data scientists and over 300 unit tests. We do require at least 1 unit test for data scientists, so there's some bias there. The full test suite runtime, I wanted to call this out, but the full test suite runtime takes 22 minutes in a CI environment. We did right out of that implement just like a selective testing where, if you change just one model, we're running the affected tests as in like the upstreams and the downstreams there. So in CI, that takes about 3 minutes because each test is really a round trip to BigQuery in this case. And even though they're short queries, it does add up, and it is a relatively slow test compared to traditional kind of software development tests. And I wanted to give some data scientist testimonials on how this is going from a variety of backgrounds. So we had a new data scientist, Jenny. She's new to Shopify. She was new to data science. And she started working in our system and sort of sent a screenshot saying like, hey, I think something's broken. For some reason, my actual model has 2 rows, but the expected only has 1. Kind of came back a little bit later and realized it was her model and that she has kind of control to change this. I came back and was not that helpful and just said like, yeah, probably it's here. But I think within like 30 minutes, she fixed it, said the test is passing, and she ended up adding, I think, 13 tests for this, which is maybe a little bit overkill. But I think she just found that the first happy path that she tested already had like duplicate data with unit testing. We also had a really interesting conversation with the senior data scientist, Cody, recently, who has fully adopted test-driven development for his data practices as a data scientist. He does it not only for his data modeling workflow, but also for ad hoc requests from stakeholders. He'll go and set up like a dummy DBT model just so that he can use the unit testing and get a really quick iteration speed locally, since each test only takes a few seconds to run with some static data. That's all I had. I hope I didn't go crazy over time. Thanks everyone for listening.